What's your assessment so far as Aquarius being an analog to spaceflight? Is it giving you a fairly realistic feel, or your crewmates who haven't been to space before?
Actually, we have talked about this among us, and in my personal opinion, this is the most accurate analog I've ever been into. I've done other analogs, one underground, for example, which is more about exploration. But this one, just because of the conditions and because of the habitat itself, it is incredibly accurate. It really feels like you are on a different planet.
Give me the thumbnail version of what NEEMO 20 is about. What are you guys there to do?
Wow, NEEMO 20 is about a lot of different things. The main thing is evaluation of procedure, techniques, and tools for future exploration on extraplanetary objects. We have been testing and evaluating flight-specific tools designed to explore, to retrieve samples, and to do science on small asteroids or bigger moons or even Mars. And the reason why we can only do it here, or the reason why NEEMO is such a unique place to do it, is because thanks to the water and to the buoyancy, we can simulate different levels of gravity, from microgravity, so completely floating, to partial gravity, like we would experiment on the moon or on Mars.
Has your own experience, and specifically your spacewalking experience, has that really helped you in that evaluation?
I think it does in many different ways. There are two ways to see this. You can have an experienced spacewalker come in and use that experience to evaluate a tool, to evaluate a technique, to evaluate a procedure. On the other hand, you can have people that have been trained but have never experienced it, and they can give their best evaluation, and it will be just as important, because we may have people that have never done an EVA on Mars, and they will have to use the same tools, the same technique and procedures. And so we can learn a lot from combining those experiences together.
Another thing that you're doing there, you're working with some European Space Agency sponsored hardware that is designed to let an astronaut keep his eye on the job instead of looking away to the instructions. How's that going?
So that part of the experiment is completed. We did it in the very first part of our mission. The hardware developed by the European Space Agency is called the MOBI-PV, and it will be used in the upcoming mission IRIS with my classmate and colleague Andres Mogensen. When he goes up on the space station this September, he will be using this special device that he can wear on his wrist, and from there, through his voice, he can command a procedure to just scroll down, which is something that can be very useful if you are using your feet to stabilize yourself and you need both hands to perform the task. So thanks to this device, hopefully we will have an improvement on that. And the experiment went really well. I think that Andy is going to have a very good tool available for him in his mission.
You've got another high-tech looking piece of hardware there on the table right in front of you. Tell me what that's about.
So while we were here, we also evaluated two different sets of augmenting reality devices. This one is a prototype of the so-called HoloLens. You wear them just like glasses. You put them on your head, and then through these visors, you have holographic images that are superimposed on reality. So instead of talking about virtual reality, we talk about augmented reality. And we use them for two different kind of procedures that are both called just-in-time training. So we have a teleoperator telling us how to run a procedure, and today we actually performed simulated a medical diagnosis using an operator outside that talks to me and guides me by seeing what I see and by telling me what to do. The other one is called ODG, slightly different. The procedure is already memorized in the glasses, and you just have to position yourself in front of the object that you need to interface with, and then the glasses will tell you what to do once you are there.
Another thing that you folks have been working on is figuring out how to have conversations when there are long delays, as there will be on future missions, much longer than the delays that you and I have right now. How has that gone?
So that has been probably one of the most interesting parts of this experiment. We simulated a zero delay time, 5 minutes and 10 minutes, simulating to be in a lunar orbit, or in orbit around on Phobos, orbiting around Mars when when the distance is close enough, or being at the farther away area of the orbits on the surface of Mars. It turns out that voice communication is very ineffective at that point. It's just hard to send a good, clear message, understand the communication by voice. And so we've been using a different tool called Playbook, which is also a prototype development for this kind of exploration. And instead we've been using text messages with attached files, videos, photos, to try to make the experience the clearest possible. And we have found out that when we have a lot of delay, the astronauts need a lot of independence in coming up with a plan in case something goes not as planned, and they need to have a very good understanding of the requirements of the mission in order to come up with the best possible plan.
Luca, thanks for bringing us up to date, and good luck with the rest of your NEEMO mission.
Thank you very much. NEEMO has been a fantastic experience so far, and we can only think that it's going to get even better.
It's European Space Agency astronaut Luca Parmitano, who is the commander of the NEEMO 20 mission, now underway under the sea.